Hello. On request of some of the students, I am once again sending certain numericals connecting to the Gauss's law and its applications. Okay. So let us write it like this. It is we will be studying this one, that is Gauss's Gauss's law and its applications. So this one we will be studying here. So you know the Gauss's laws, the expressions of the Gauss's laws come E dot ds integral, that is equal to q by epsilon, and that is equal to flux, the electrical flux. So it comes like this. Clear? So let us do something about the Gauss's law. And what we will be doing today, let us learn about how the electrical field is connected with the potential. So what we will be writing? We will be writing dV by dr, that is equal to minus E. So it is in the opposite directions. Clear? So voltage, this is increasing and this is decreasing like this. Clear? So with respect to the distance. So what we will be writing here? We will be writing, suppose we will be doing a sum from the H.C. Verma, that is the equipotential surface on a equipotential. Suppose this is a equipotential surface line we are drawing. So this is a line which is having 10 volts. Clear? So what is this indicates? This is indicating that it is a clouds layer which is having the voltage always same 10 here. Clear? So like this. Now take another layer of the clouds like this. Okay, and this is having 20 volts. So another layer of the clouds like this, and this is having 30 volts like this. So in this way we are drawing the equipotential surface. This equipotential surface is at a distance of 10 centimeter. Clear? So now what we will be finding out? We will be finding out from these relations. So what is the electric field at this point? Clear? So now let us draw just a line here in this way. So this is x and y line. Okay, this is the distance and this is x. So this is having an angle theta, this is having an angle 30 degree, and this is also having an angle of 30 degree here. Okay, so these are the angles that it has drawn. Now we'll find out the electric field. Electric field always will be perpendicular to specifically the equipotential surface. Okay, this is the equipotential surface, it will be perpendicular outside the electric field. This we can prove from here, as we know that dV equals to E dot dr. So we can write like this. dV in this line is 0, so we will be writing here 0. This is equal to E dot dr. Clear? So in this equation we write, if we are expanding it, so it is E dot dr cos theta. So this theta, cos theta, so here it is cos theta. So this cos theta would be how much? 90 degree. As it is 0, so E cannot be 0, or else dr is not even 0. So it is 90 degree definitely. So it will be at 90 degree here. Clear? So this is at 90 degree and this is at 30 degree. Clear? This is at 30 degree, this is at 30 degree, this is at 30 degree. So this is 30 degree and this is 90 degree. So it is 120 degree away from the line, from the surface. So what we will be writing? We will be finding the electric field. So we will write that E dot dr. Okay, this is dr, the distance, that is equal to the q by epsilon. Okay, and this we will be writing Gauss's theorem. So we are writing that this is E dot ds, that is equal to q by epsilon, that is equal to phi. So this is we are using in case of finding the flux. Now we will be finding out the E. So we will be writing a formula like this. So it is E dot dr. Clear? So this is equal to the dV. Clear? So now we'll find out what is dV and what is E dot dr. Clear? Here dV is the 10 volt. Here it is 20 volts and here it is 10 volts. So we can write that dV equals to 20 minus 10, that is equal to 10 volts. So we will be writing here 10 volts, and here we are writing E and dr. Dr is 10 centimeter, so we are converting it to meter, 10 to the power minus 2 meter, and cos theta, as we will be writing here the cos theta. So we know the value of cos theta here is 120 degrees. So we are writing E, here it is 10 to the power minus 2 it is into 10, and it is cos 180 degree means half here. So we are taking these things here, and we find that here by making simply calculations of this one, we get it at 200 volts here. It is going and multiplied, this 10 is coming down and this is going up. So it is 200 volts, 200 Newton per coulomb. This is the electrical field here. So one problem that we could find out, the between the layers there is 200 volts, that is electrical field. Clear? Electrical field here is between these two equipotential surface, electrical field is 200 Newton per coulomb. Clear? So this is what we have learned about the electrical field. Let us do certain other sums. So it is clear to you, I am rubbing it off. Let us do some other sum regarding the Gaussian surface. So that you must be knowing what is Gaussian surface. Gaussian surface is a surface that we are writing like this. Suppose we will be doing another sum from the HC Verma. So this is a surface. Okay. So we can show a surface like this. Clear? Suppose this is a surface we are showing. This is a surface that we are showing, a surface like this. Above this surface there is a charge kept here. Okay. So we will be showing the charges like this. So this is the Q, the charge is kept here. Clear? So this is at a distance a by 2. So this is at a distance a by 2. This is a distance a. This is a distance a. This is a distance a. So it is a square. So we will be finding the flux through this surface. Clear? So how this is possible? Then in this case we will have a we will be taking this Gaussian surface here. So we will assume a Gaussian surface. In order to assume it, we will be drawing a lines like this. So this is one line, this is one line, this is one line, and it's becoming a square. So we are enclosing this one. Okay, so this one we are enclosing, and here we are getting a square. So this is becoming a square like this. Clear? So like this, once again I am drawing it. So this is a square type of structure. So in this square, where is the charge? In the middle position. This is at a by 2. Here this is a. So it is at the middle position, at the center. So how much will be the electrical flux? Electrical flux will come out like this. It will be going to this side, it will be going to this side, going to this side, going to this side, again in this side, again in this side. Like 1, 2, 3, 4, 5, 6 sides it will be having. Clear? A square is having the 6 sides like this, and will be coming out from that those sides. So we will be finding out. We know that Gauss's theorem gives us E dot ds. Clear? This is equal to the Q by epsilon. This is equal to the phi. So total flux to the surface areas is phi. Here it is clear. So it's going to all the directions and outward, as we have assumed it to be positive. So what happens? How much will be the charges through this one surface? It has got 6 surfaces. So we will be writing E into 6 surfaces S. So by integrating we get the total 6 surfaces. So it is equal to the Q by epsilon, that is equal to the phi. Clear? So in one surface, how much will be the electric flux? That is Q by 6. Okay, 6 epsilon. It will be divided by 1/6. So total is 6 surfaces. So it will be divided by 1/6. So phi dash will be q by 6 epsilon. So in this way we will be visualizing how the Gaussian surface is drawn. You will be getting these sort of things in the examinations, and like this and this and this, you will have to do it accordingly and conceive it and follow these things in this way. Clear? Now let us see another surface, that is we have chosen another sum, that is suppose a semicircle. Okay, so if it is semicircle, then how will be doing this? Suppose we have taken a semicircle. So this is a sphere, correct? This is a sphere. In this sphere we have kept a charge at the middle. So this is a semi-sphere. Okay, half of the sphere we have taken here. Then how will be finding the flux to this sphere? Okay, so will be taking the full sphere. Okay, and this is the charge at the middle, and this will be conceived that there is an imaginary surface on this. So here also we can write that E dot ds, that is equal to integral q by epsilon, that is equal to phi. So we will be writing here what E into 4 pi r square. This is r, so 4 pi r square, that is equal to q by epsilon, that is equal to phi. So this is the flux to the total surface area. So we will be finding through half of the surface area. So it will be how much? The flux will be half of this, that is q by 2 epsilon 0. Clear? So this is, you know the tricks now, no? How it can be done. This is the way we are doing the sums in this way. So let us do another thing, that is about a solid surface. Suppose we have taken a solid surface sphere. In this type of solid sphere we are taking. Here in this sphere we will be finding out the electrical flux. What we will have to do? Suppose we have given charges here, so it will be scattered all through the volume. So we will be finding out these things by volume density, Q by V. So total charge is given, suppose Q, capital Q, and by volume, that is Q by V. We will be finding out in this way. So once again, let us choose a sum. Suppose how much? Suppose a radius of the gold is 7 into 10 to the power minus 15. So it is given that radius of this gold is 7 into 10 to the power minus 15 meter. Here this is the radius of the gold, and the gold nucleus is containing 79 protons. Here this is the nucleus which is containing 79 protons. What is the electric field at this position, and what is the electric field at the middle of this position? We'll have to find out this one. These sums will be doing in the similar way as we have done in case of a solid sphere. So solid sphere, you may be knowing what is the formula of the solid sphere, that we have written in case of solid sphere, the formula, that I am giving you this formula, and you can use these formulas also. Clear? So in case of a solid sphere, we will be writing like this. We will be writing the formula in case of a solid sphere, that is electrical field E equals to, we will be writing electrical field E equals to E rho by epsilon into 3. So this we have proved earlier. So now we will be using this one here. So in this case we will be writing R here, the radius, and capital R as the radius of this one. Okay. So in this case of sums, we will be finding out first the rho. This is the charge density. So total volume of this is, we are writing 4/3 pi R cube. Okay. This R cube we will be writing here as capital R. So this is R cube, this is given. So we'll be writing volume 3/3 pi r cube means 7 into 10 to the power minus 15 whole cube. Clear? So this is the radius, this is the volume of the sphere, and we have got 79 protons. So 79 into 1.6 into 10 to the power minus 90, this much of coulomb of charge it is containing. So this divided by how much we will be writing? 4/3 pi into 7 into 10 to the power minus 15 meter cube. This is the rho, the density. Clear? So we find out the volume density of this surface. So this is rho, the volume density that we will be doing now. The simple calculations by putting this formula. So what will be the formula? Formula we have written 3 rho by r. This you can see my previous things and you can find out from there. This we can write this simple formula in this way. So at the surface we are writing what happened at the radius this surface. This is r. So these are and these are cancelling. So at the surface it will be 3 rho by epsilon. So rho we can find out in this way, and we will be putting this one and we get at the surface at A. Suppose it is at A. At surface. S-U-R-A-F-A-C. So this is at a surface. So in the middle position like this, what we will be writing? We will be writing at the middle position, suppose at any position, say x. So we will be writing 3 rho into x divided by epsilon. Okay. So 3 rho into x divided by epsilon, that will be writing like this. Clear? So x by 3 rho will be writing in this way at any position here. So electrical field, suppose we are putting back this value and we can find out even at this position. Suppose this is at a position x. So what will be the value? The charge that will be held in here, it is 3 by 6. Suppose this is excess q into rho. So this is the charge q dash it is holding. So we will be writing this one charge enclosed by the surface. So E equal to 4 pi r square. E dot ds it comes. This is equal to the q dash. Q dash will be writing 4/3 pi excess cube into rho divided by will be writing how much? Divided by epsilon. Okay, so this is q by epsilon. Here we will be writing the value of the rho that we got from here. Clear? We will be calculating this value and we will be writing it here, rho. So by substituting these values of the rho, and we get the electric field E as 4/3 pi excess cube into rho by epsilon divided by 4 pi r square. So this is excess square we will be writing. Clear? So this one and this one will cancel and it will be coming 4 will be cancelled, and it will come a simple formula like rho divided by x by 3. X by 3 here comes. This 3 will come down. So x by 3. Clear? Rho epsilon by x by 3. So we know all the things. So we'll put it back here and we'll be getting the answer. So first answer here, if you are calculating, so you'll be getting 2.11, likely this much of Newton per coulomb. Okay, and this is almost 1/3 of it. So we'll be calculating this one with the x and we'll be putting back here and we'll be getting the values of this one. Okay, so this one you can calculate yourselves, and this one I have already calculated, and it is 2.11 Newton per coulomb. Okay, thank you students. Thank you for attending this. I feel you could understand these things very well. Okay, now you calculate this and you show me how the answers comes in this case. Okay, if you don't understand, ask me.